So the first topic is the Lewis dot structure. Lewis dot structures are diagrams that show the valence electrons, the outermost electrons of an atom. These electrons determine how atoms bond with others to form molecules or compounds. Um, the goal is to reach a stable configuration, often like a noble gas. Okay, so for the first example, so oxygen has six valence electrons, and each hydrogen has one. So it has a total in total we have eight. Sorry, in total we have eight valence electrons. Two electrons from the two HO bonds bond, and the remaining four electrons are placed as two pairs on oxygen. This explains what Jesus. This explains why oxygen has those two dots in the structure. Somebody had to.
I can't tell. Let's see. Yes, I'm it's right here. Tell me right now. That's what but
You left it outside?
I don't know. Oh my goodness. Then I had takoyaki, which is the octopus meatball. Not octopus meat, octopus ball. It's basically just like pancake butter.
For the next example, carbon has four valence electrons and oxygen has six. So the total is 16. Each double bond uses 4 electrons, leaving 4 electrons on each oxygen as lone pairs. That's why carbon dioxide has a linear shape. Um, this is the 36th example, and this is ammonia. So nitrogen has 5 valence electrons. Um, three hydrogens contribute one each, making 8 electrons. 3 electrons are shaped in NH bonds, and 2 remain as a lone pair, one nitrogen.
What you gonna do for it?
So the connection that um so
I would do this whole thing by myself too.
so the connection that this has to nursing is understanding these bonds help nurses know how electrolytes and gases like oxygen and carbon dioxide move in the body, which is vital for patient care and respiratory function. Now we're going to talk about the VSEPR theory. Um, so the VSEPR theory predicts a molecule's 3D shape. Since electron pairs repel each other, they spread out as far as possible around the central atom. Um, the shape determines molecular in how a molecule the shape determines how a molecule interacts with other molecules. So this is the VSEPR theory. There's some images of yeah. Before we start these examples, we have to remember to count the total electron pairs on the central atom. That's bonding pairs plus lone pairs, and match them to a shape. So for this, the first example, for the first example, we have water. 2 bonds plus 2 lone pairs give 4 electron pairs, forming a bent shape with a bond angle of 104.5 degrees. For example 2, we have methane. So 4 bonds and no lone pairs gives us a tetrahedral shape um, with bond angles of 109.5 degrees. Next thing. For the last example, we have ammonia. So three blo- 3 bonds plus 1 lone pair make a trigonal pyramidal shape. The bond angle is slightly smaller, around 107 degrees, because Lone pairs push the bonds closer together. The last topic I'll be discussing today is chemical nomenclature. Chemical nomenclature is chemical nomenclature is a system scientists use to name compounds. It helps us know how elements and how many atoms are in a compound. I found an example of, I found an example of ionic compound and covalent compounds. These are some like the example. These are some of the examples. So for our first example, um, this is sodium chloride. Sodium chloride gives us one electron to chlorine. The equation is Na plus Ci gives us NaCl. Simple.
I'm gonna find it.
Okay, so for the first example, sodium gives us one electron to chlorine. The equation is sodium plus chlorine, and that gives us sodium chloride, as you can see. So NaCl. For the second example, we have magnesium oxide. Um, so magnesium loses two electrons, and oxygen gains two. Um, that will form them into magnesium oxide. Now for the third example, this is carbon dioxide. This is a molecular compound. The prefix Di shows two oxygen atoms. It can also be formed by the reaction. Carbon plus oxide gives us carbon dioxide. So all of these topics helps nurses know how molecules like drugs and nutrients are built. The VSEPR theory shows the 3D shape of molecules, which affects how medicine and protein interact in the body. Finally, chemical nomenclature ensures nurses can read labels and administer medications safely, preventing errors in patient care. Yeah.